Night.
To do roots and vertices, there's two steps in one here. The roots, you got to factor and set equal to 0. This factors to be x plus 4 and x minus 2. Because when you add those together, you get 2, and when you multiply them, you get negative 8. However, since they're equal to 0, you're going to subtract 4 from both sides. So one root's negative 4. The other root's a positive 2. Your vertex, on the other hand, is going to be slightly different. The vertex you can get by completing the square. And I'll do that down here. Maybe I won't. Well, negative 4. Yeah. Okay, so negative 4, 1, 2, 3, 4. And positive 2. One thing we can do would be to find the middle of that. And if you count 1, 2, 3, 4, 5, 6, there's a span of 6 between. If I cut that in half, I'm down here, right there in the middle. Now that's not, I shouldn't have put that. That's not a root. But the fact that negative 1 is in the middle of those two, that's going to be part of my vertex. This is one way of finding the vertex. Now the question becomes negative 2, negative 3, 0, and 1. What is the value when I plug negative 1 into the equation? Well, I can plug a negative 1 in here and here. This is one way of doing it. Okay, that gives me a 3, and that gives me a negative 3. So 3 minus 3 times a negative 3 is going to give me a negative 9. So this is negative 9. My vertex then is at negative 1, negative 9. Okay, so again, that's one way of doing it. Completing the square is another option. But now all we need to do is plug in another couple things. The coefficient out in front is 1, so one thing I could also do, 1, 2, 3, 4, 5, 6, 7, 8, 9, is do the stair-step approach. And that's to say I'm going to go up 1 and over 1, put a dot. I'm going to go up 3 and over 1, I'm going to put another dot in both directions. And then I'm going to go up 5 and over 1 to get the last dot, which gets us right to where we need to be. Again, multiple ways of doing it. That is one of them. The nice thing about this one is it's in a form to where I can identify both the root and the vertex. This one here, the root is at 3, 0, and the vertex is at 3, 0 because the root is the vertex. If we're going to graph it, though, we need to pay attention to that. So it's upside down. Down 1 and over 1 is going to give us the first, and then down 3 more and over 1 is going to give me the next. And then that is, in fact, 3, 0, 2, 1, 4, 5. We do the same thing. It's going to be a negative 1, and then down 3 more would be at a negative 4. And so that's kind of the direction you want to go. When you're looking for roots, you're factoring. Take out a 2, x. You're left with an x plus 2. If you set that equal to 0, you have a root at 0, 0. Set that equal to 0, and you have it at negative 2, 0. That right there is going to be the first 2 points. And the fact that there's a 2 out in front means you're going to have a multiplier of 2, which means your first step is going to be down 2. Another thing you could also do, like we did in the first one, is plug in a negative 1 into your equation. A negative 1 in here. Let's do it down here. 2 times negative 1 squared plus 4 times negative 1. That's going to be a positive 1 times 2, which is 2, and that's going to be a minus 4 because of the negative 1. So that gives you a negative 2. So at negative 1, you've got a negative 2, and then that will give you at least the first couple points. You know, the other 2 points are 0, 0, and negative 2, 0. And I'll let you fend for yourself on the last one.